Hello, today I have a video on linked lists. We'll be going through structs, and yeah, the reason I'm making this video is, well, I was explaining this to a student and a friend of mine suggested I should put it up in a video for everyone. So here we go. Okay, first we'll cover a bit about structs. The way structs are set up is you have struct, we usually put an underscore, say this is a struct for a student struct. Alrighty, what should a student have? Well, let's say a student has a ZID, a student also has an age, and maybe a favorite number. Alrighty, so our struct underscore student has ZID, age, and favorite number. I made them all ints just to keep it simple. So, and what we do with structs to make it clearer is we typedef them. Now, typedef looks like this, and as you can see here, it takes an existing and a new. Now, if you're not familiar with typedefs, a good way of thinking of it is it's like a hash define, except for types. So when you have a hash define, you would have your label. So say, I just put in new, and then you have existing. So for example, hash define true as 1. Now, whenever we see true, it's replaced with 1. So typedefs, let me just write this in a comment here. Typedef, it's a bit backwards. So we have the existing first, and then we have the new. So just remember, typedef takes in 2 arguments. So to typedef our struct, what we do is typedef, and now this whole thing here is actually our existing thing. It's the thing we want to rename. We want to give it a new type name. So the new type name will be student. It's just whatever you have here without the underscore. It's always good to put the underscore there. It's just a matter of style. Okay, now, next, how do we access this struct? Okay, so remember, you now have the type student. So, just like we'd define any normal variable, like an int number equals 11, you use the type student to define a student. I'm just going to declare it first. So student Bob. Then, to access things inside the struct, we go bob.age equals 19, bob.favorite number equals number, bob.zid equals 3468 or whatever, blah, 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 blah. Alrighty. So that's how we access things in a struct. Okay, so the next thing is, say we want to make an array of students. How would we do that? Well, how do you make an array of ints? So what you do is you go int numbers, and you say maybe 10 numbers, and you can set it as 1, 2, 3, 4, 5, 6, 7, 8, 9. That's how you do an array of ints. So how do we do an array of students? Just the same. Remember, student is a type. So you can go student, and let's say these are all the computer science students. Let's say there are 100 computer science students. Now, imagine Bob is our first student. To add Bob, we would go CSC students 0.age is equal to 19. His favorite number is our number. Let's say it's, just so I can access that struct, let's say it's the number 4. So it's going to access this one. Alrighty, so you may have seen the arrow notation. So if you're not familiar with this, I'll explain for you now what it means. So now that we have this type student, we can typedef that as a student pointer. Now, this line might be a bit confusing at first, but to read it, all you have to remember is that typedef has 2 arguments. The first argument are these elements here. So struct underscore student and the star, which means pointer. So how this reads is, and this is the second argument, how this reads is student pointer is a pointer to the struct underscore student. Now we could replace this with student, because we have hash defined, we have typedef, student down here. But if we use the struct, it just makes absolutely clear that it's a struct. So next, we want to do this all again, except this time we just want to use student pointers. Now I'll be introducing you to the malloc command. Now, what does malloc do? Well, if you're ever stuck wondering, what you can do is you can look it up in the terminal using the man command. Man stands for manual. So what I would write is man malloc. Right. All this may look pretty confusing at first, but hone in on malloc here. Now what this is saying is malloc takes in the size in bytes and it returns a pointer. The void just means it can be a pointer of any type. So that's the little asterisk that means it's a pointer. So what malloc does is it will allocate some memory for you on the heap and it will return to you a pointer to that allocated memory. Now you have to remember that it returns a pointer. It's one of the common things that's forgotten. You can't just start writing malloc like that. You have to make it equal to something. So why don't we make our new student, Bob, again, like this. Student pointer, Bob, is equal to malloc. Now, what are we going to use for the size? We've got Bob, who is going to be a pointer to an area of memory that's allocated for this struct. So what we're going to need is the size of the struct. If we look here, we can probably make a guess at how big this size is going to need to be. So say an int is 4 bytes. We will need 1, 2, 3 ints. So 3 times 4 is 12. We'll probably need 12 bytes for this struct. But this might change depending on which computer you're using and how much memory it has. So in this case, we're just going to use size of. What we need is the size of the struct. So we could go struct underscore student. There we go. So now we've allocated some memory. Now, before we used bob.zid to equal, say, alrighty. But Bob is not a struct anymore. Bob is a pointer to a struct, right? Student pointer is a pointer to a struct underscore student. So this is where you use the arrow notation. Because Bob is not a struct, it's a pointer to a struct. You go arrow. That's where you use the arrow. So, for example, Bob arrow age equal to 19. Bob arrow favorite number is equal to 11. All right. So now that we've covered that, let's say, for example, now you do something tricky. Say we wanted to give Bob a kind of mini-me. Well, thing is, now that we've set up a student pointer, our pointer to struct student, interesting thing now, we can actually put, because remember this is a type, we can put a student pointer inside this struct. Let's call it inner child. Alrighty, now things get interesting. So now that Bob has an inner child, we could go Bob inner child, and the inner child has all the same properties. So age equal 18, we can have the ZID equals, just making up a number, then we can have his favorite number is 12. So it's like having a student within a student. Now, if that hasn't blown your mind, you can also see that Bob's inner child, now remember inner child is also a pointer to a struct like this. So Bob's inner child also has an inner child, and that inner child also has another inner child, and so on. Alrighty. Now technically this code isn't correct because we haven't allocated memory for each inner child. We've only allocated enough memory for the size of one student struct. We could go through and allocate memory for each inner child, but take this as a theory of concept, and we'll be doing the allocation of the memory for these inner things a little later. Okay, imagine now instead of having student pointer, we call this node pointer, and call this one node. Now we're starting to get to the beginnings of what is a linked list. Okay, that will be the end of this video. I will continue on in the next video.